6. Let us commence with electrostatics. The first one under electrostatics is electric charges and electric field. Electric charges and electric field. The study of this is known as electromagnetism. Electromagnetism. It has two categories: electrostatics and electrodynamics. Electrostatics and electrodynamics. The electric charges which may be at rest or at motion. There are two possibilities. The electric charges may be at rest or at motion. If the electric charges are at rest, the subject is known as electrostatic. The subject of study is known as electrostatics. If the charges are at motion, the subject of study is called as electrodynamics. Example of electrodynamics: it is electric current. It is electric current, magnetism, EMI, electromagnetic induction, AC, DC, etc. It is sensing of electric current, magnetism, all are electrodynamics. This study is mainly because of electric charges. What are electric charges? Electric charge is an intrinsic property of matter. Electric charge is an intrinsic property of matter. Let me recall the matter which exists in three different states: gas, liquid, solid. As you know, all matter is made up of the most fundamental building blocks are known as atoms. Now, as about 120 atoms we have discovered. And in some cases, the atoms will change into molecules because of the electron-electron interaction in the outermost shell. But whether it is the atomic substance or molecular substance, the fundamental building block is atom. What is atom or composition of atom? As you know, it is a nucleus, central nucleus, carries positive charge because it contains protons and neutrons, and electrons surrounding the nucleus. Electrons carry negative charge. The fundamental particles are positive: the proton, neutron, and electrons. These electrons are loosely bound electrons, electron cloud around the nucleus. In some materials, the outermost electrons are loosely bound. In some materials, the outermost electrons are loosely bound, and these electrons can easily, pass or flow, transfer, that is, easily pass through the material. In gases and liquid, the fundamental building blocks, that is, atoms and molecules, themselves move. But in solid, these particles are fixed. Atoms and molecules are always fixed. But in some cases, the outermost electrons of the atoms can easily flow all over the material because they are loosely bound in some cases. Loosely bound electrons, they can free and just they flow like gases in the space. They flow all over the material, all over the object, the solid object. And not only that, they can also move out of the object as well as the electrons. So in that case, the electron exchange is possible between the two different objects, of course. If electron is exchanged, that is electron is exchanged or electrons are exchanged, resulting in what is that? A gain in electron, loss in electron. An object, there are two objects. Now electron, what is that? Some electrons, what is that? Come out of this. This object is losing electron, this object is gaining electron. So gain of electron, the object acquires or possesses negative charge overall. Loss of electrons, the object acquires positive charge. So this is a result of electron exchange that is possible. Electron exchange, electron flow in the material, in the solid is possible, and electron exchange is also possible. All because of this. This arises electromagnetism, electric charge, and electric field. As you know, the electron is a fundamental particle. That electron, single electron, and the gain in charge or loss in charge, either negative or positive. The amount of charge this object gained or amount of charge this object possesses is always is equal to this. Q is equal to plus or minus n into E. That is amount of charge. Here Q stands for the symbol of charge, electric charge. Plus stands for positive charge. Minus charge for negative charge. Here electron rich, electron deficient. N represents number of electrons exchanged between these two, and E stands for electron. Ne. And there is a net charge. So after this, what is that? The charge remains same. It is negative, it is positive after the exchange. And that is the amount of charge. And as you know, fundamental electron charge. Now, this electron has a charge unit. Unit of charge is coulomb. The small electron possesses the charge, amount of charge 1.6 into 10 to the power of minus 19 coulomb, a small amount of charge. This coulomb stands for a unit of charge. It is a scalar. It is not a vector, it is a scalar, magnitude of charge. 1.6 into 10 to the power of minus 19 coulomb. So that is charge per single electron. And the total amount of charge that is gained or lost possessed, it is estimated in terms of number of electrons. What is gained, number of electrons, what is lost. That is n into this. Estimate what is the amount of charge on this, what is the amount of charge on this. So that is called as integral multiple of E. It is known as quantization. So this charge is always quantized. Quantized means 1 electron, 2 electrons, 3 electrons, there is 1 quantum, 2 quantum, 1 quantum, 2 quanta, 3 quanta, integral multiple. Each electron is 1 quantum, that is either radiation or particle, either in terms of this 1 quantum. So that is what n into E. So this charge is called as, what is that? Amount of charge, the symbol, and the unit is coulomb. It is always a scalar. The electric charge is a scalar, not a vector. And this charge, exchange of charge is taking place among the different objects in the nature. And if you take the system, entire system is isolated, there is entire universe or something like that. And these objects can exchange electrons. Gain electron, lose electron. But acquire negative charge, positive charge. But overall, what is that? The amount of electric charge remains same. The number of electrons and number of protons present in the entire matter remains same. That is called charge is always conserved. Just like energy, conservation of energy, it is a conservation of charge. Law of conservation of charge. That is called an isolated system. You can see the objects of different charges, but the entire charge remains same. Overall, the system enclosing all those objects is called as isolated system. That is one more concept. Now regarding the charge, I'm talking about this. Charge and mass, they have their, what is the relationship between these two? As you know, the charge is either positive or negative. Electron loss, electron gain. The body can acquire positive, negative charge. There are two possibilities. Mass is always positive. There is only one direction towards attraction. That is, and this charge, electric charge, can be at rest or at motion. Whether it is at rest or motion, the magnitude of charge remains same. That is independent of speed. Whatever mass, it is a mass that is at speed dependent according to the equation, aquatic equation. That is m is equal to m naught divided by root of 1 minus v square by c square. M naught stands for mass at rest. M stands for mass at speed of v. Mass of the object when it is going at a velocity of v, where c is equal to velocity of light. Look at that. As the speed increases, mass increases. Mass is a dependent. As the speed increases, mass increases. That is mass at rest. So there is a variation in mass. But charge magnitude is not varying with speed, but mass magnitude varying with speed. That is the equation for that. That is from the Einstein's one more relativity. That is Einstein's equation. But you look at a particle of charge, that is electron is the smallest particle, that is almost weightless, but this charge carrying mass. Assume to be weightless, it can jump from one object to other object. And that is comparison, there is 1 AMU, 1 unit of mass, that is amount of charge, that is mass. Is 1 unit of electron, one single electron as mass is. Compare this, the mass of electron is 10,000 times less than the 1 AMU, the mass of protons and neutron, like that, almost. That is comparison. Still that the electron possesses this energy, that is mass. The amount of charge one electron possesses is this, and the amount of mass the electron possesses, single electron possesses, this is the amount of mass in kg second. So this is about regarding the fundamental aspects of the charge, electron charge, positive charge like this. It said gain and loss. By this we can create what is that a charged bodies like this. Practically, how can you convert, that is make the body into a charged particle, that is a charging, the negative charge and positive. How can you get an object of negative charge or object of positive charge? By charging. How it is charged? That is electrostatics. There are three methods. That is 1, 2, 3. By conduction, direct contact method. By induction, not in touch, no touch or no contact between them objects. Here by rubbing or friction. There are three methods by which we can get the object into a particular charge, as positive charge or negative charge. That is, already object is there. Object containing what is negative charge, electron excess. When you bring a charge neutral, no charges, no net charges. Here net charges negative. When you bring these two closer to touch with each other, when they touch with each other, this electron rich here, this electron can flow from here to here. As yet, not an electron can flow all over the object and also flow out of the object into this. Now electron can share, there is exchange electrons. So this exchange, that is electron flow until it attains equilibrium, equal charges, negative charges. If there are 2 electrons, 6 into 6 divided, that is charge. So already charged, this is also charged. Look at the second part. This way of charging, direct contact. If you have positive, that is positive, sharing. That is by direct contact. By induction, no touch with each other. Inducing charge. How it is possible? An object with negative charge, electron rich, object neutral. Let us bring very close to each other like this. This is electron rich. This electron rich influence on this material because contains negative electrons and positive charge. Because of electrons, what is that? The electrons on these atoms and molecules move that side because of negative repulsion. So only what is that? It is not coming out. It is called separated. Electrons constant accumulate on the other side. Here deficient electron. It is called polarization. Negative charge, positive charge. A line of negative charge, a line of positive charge. Alignment will align like this because of this bringing close to this material. It is called polarization. Now electrons are concentrating on this, but it's not coming out of the material, concentrating on the other side. So now when you bring one more object, neutral object, touch with this in the side, because electrons are accumulated here, now it can flow easily. There is a spontaneous flow. Electrons can flow easily from here to here. And against negative charge here. Electrons flow from here. So because of electron loss, because accumulated and flow, when you bring in touch with this, this material. But here not, this is not in touch. When a material like this, after polarization, when a material like this touch with this, now electrons flow like this. That is charge, negative charge, positive charge. Now the material what we have here, this material becomes positive charge, this material becomes negative charge. We get both positive charge and negative charge materials like this. This way of charging, that is by induction. And another, the same concept we are using, you are using the object of positive charge. Object of positive charge. It is brought very close to the material. It is a neutral, like this. Neutral polarization because of this. This is the way of polarization, alignment. Negative charge, this side positive charge. Now this side electron deficient, this side electron rich because polarization towards this. Now when you give the contact of this surface, this side towards the earth, to the earth only. As you know, earth is electron rich, the ocean of electrons. Earth contains so many metals and metal compounds. Electron rich. When you give a contact like this, there is this side. No electrons are there. Abundance of electrons are there. Now can flip because of polarity, positive charge. Electrons can easily flow from your earth material to this material and neutralize this. When they enter into this, neutralize this. This electron gain overall becomes positive charge. And the electron from here to here, it becomes what is a neutral becomes negative charge. That is another way of charging a material, get negative charge like this. That is a way of charging. And the last one by friction. Friction means rubbing two materials. The materials of course insulators. That is these two materials, different types of materials. Upon rubbing, what happens? The heat radiation produces thermal energy. These heat radiations, what is that? That is of one type, what is that? There are two different. This is one type which can gain the heat radiations. The heat radiations, what is that? It can gain and knock out its electron because the radiation gain, no, the energy gain, knock out the electrons, outermost electrons. That is a kind. Easily, electrons are knocked out by the radiations. But in this case, electrons are not easily knocked out. But what the electrons knocked out can easily gain this. So this material, some electrons are knocked out, pass on to this, will gain. So the positive, negative charge, positive charge. So electron exchange, this electron exchange because of heat radiations. This material, what is that? Absorb heat radiation, and as a result of the energy, what is that? Electrons are knocked out of the material and pass on to this. So negative charge, positive charge. By rubbing, it is called by friction. We can have material like this charges. That is electric charges. Origin of electric charges. No, that is the force, electric force. Talk about because there is also a force between the electric charges. As you know, these two are the object of electric charges. This object carries negative charge, negative charge. This object carries positive charge. So opposite means there are always attraction. Negative, positive, electric current is electrostatic attraction. That is called as force of attraction. There is always attraction, some force of attraction. But same charges, positive or negative. Both are negative or both are positive. A repulsion, that is this is the direction of force. So repulsion or attraction, that That is called as electrostatic force. It is estimated using Coulomb's law. It is commenced with the point charges, very minute point charges. Done like this. This is a point of charge is Q1, point of charge Q2. Both carry positive charge. Assume that both carry positive charge. Now these two are getting repulsed. This is the direction of the movement of charge. This is a straight line drawn along the center of the two charges, because force is always acting along a straight line. Where is the line here? Line is passing to the center of the charges. That is the force. So that is the force. That is the force acting on this. This is the direction of the force. The force acting on this is the direction of the force, opposite direction. But magnitude remains same. Distance of separation. Because Coulomb's law is applicable for charges at rest. Calculate the estimate. What is that? Estimate the amount of forces between these two charges. So that is F. Why F12? F12 means is a force acting on 1 by 2. Force acting on 1 by 2. Force acting on 1 by 2. Why F21? Force acting on 2 by 1. Force acting on 2 by 1. It is a force acting on 2 by this. This amount of force. Both are same magnitude but different direction. Both are vectors. This represents vector quantity, vector. This symbol is vector. So along the line joining this, the force always acting on this. So first he has estimated the magnitude of force. What is the magnitude of force if you have taken point charges like this case? The amount of force is directly proportional to this product of the charges. Magnitude of this charge into magnitude of this product of this charge and this. But inversely proportional to 1 over r square of this. It is also called inverse square law. Inverse square law. So F is equal to together. That is this into this divided by r square proportional to. It is called proportionality constant. Equals proportionality constant. That is the magnitude of force. That is wrong. The amount of force is equal to this is. This is very estimated using what is a point charges. Where K is equal to constant. What is the K here? K is equal to 1 by 4 pi epsilon naught. One case. K is equal to 1 by 4 pi epsilon naught, epsilon. This is for vacuum. This is for some medium. Vacuum is empty space. When the space is empty, the force exerted is maximum. There is nothing to, what is that? Oppose that force. When the force is filled with some materials, the gas molecules or liquid molecules in between this, that is permittivity of a medium, some medium is present. That epsilon is called permittivity of the medium. What is permittivity? That is, if any substance is there, it will allow, it will permit, that material will permit its own electric force. Electric force is already there. If any material is there, it will permit, that medium will permit its own electric force. That electric force will oppose this electric force. That is why is inverse, what is that? 1 over 4 by K. If that epsilon naught is more, a force of attraction between them is reduces. So it is maximum and it is vacuum. So it has its own value, it is different value for different materials, water or gases like this. So that is why. So value of K for vacuum, it is found to be 4 pi into epsilon naught value is calculated by this vacuum. The value of K overall is 9 into 10 to the power of 9 Newton square meter per Coulomb square. K na value of unit K is equal to, that is this side or this side, Newton square meter, that is goes to meter per square Coulomb. minus 2 square. So it is SI unit, the value of this A SI unit for vacuum. It is what we get, value of K. That is magnitude of force between the two charges of this magnitude, and distance of separation. This is the one R. That is scalar magnitude. But this force, Coulombic force, is not a scalar itself, it is a vector. There are only scalar value calculated, but it is a vector quantity. The force, Coulomb, whether the force is Coulombic force as a whole is a vector quantity. Coulomb's law. So this vector quantity means that is what the same charges I'm talking about this. These two charges are at separation of R. Let us locate these two charges in space. So this is one charge I have taken the same charges here, Q1, Q2. That is what is the distance of separation here. These two charges need to be located in space because direction is important. What is the direction? So first we have to locate this with respect to a point, that is the reference point is 0 origin. Coordinates are required. 2 coordinates I have for this line. So what is the position of this with respect to this? That is called position vector. That is, a position vector represents both magnitude and direction. This is a direction and magnitude means the length. So position vector of this charge is R1. That is a vector. That is position vector of this is R2. That is a direction and the magnitude. What is this line? It is a position vector between these two. That is what is that? Position vector of this. Very important. So this force on this is F12 direction. Force on this is F21. And this force, let us write the both are values are same. Let us estimate the F12. F12 is a vector quantity. Vector quantity is a multiple of scalar into vector unit. That is scalar. So for this, F is equal to this. F is equal to this K into Q1 Q2 by R square means here that is the force with this, and this is the position vector. What is the position vector for this charge? This is the position vector, the direction is this. R is position vector, direction 1 2 means represent this direction. This direction represents 1 2 R direction, that is position vector of this between these two. That is why, that is with respect to this, the force. What is the force on this charge? That is F21. F21. So that is same magnitude, and that is the position vector. The position vector of this electric charge is R21. That is the direction. The same value, direction is R21. So 1 2 represent this direction, 2 1 represent this direction. Okay, the same, this value. So now we need to eliminate what is that. This is one R21. We need to find out this. What is this and this? Using these two, because these two values are known. This is a vector of this, vector of this. How to find out this vector R12 and R2 using this what vector addition, geometry, algebra of vectors. Recall the basics of algebra of vector. That is what this here. This is one vector, another vector. That is vector V moving like this direction, and this vector. The vector is moving like this. The object is moving like this, and the resultant. What is that? This vector. What is the resultant of these two vectors? This plus this is equal to, just draw a straight line slightly from here to here, triangle like this. This is the resultant of vector. So this vector plus this vector is this vector. That is the law or algebraic addition of vectors. This four same as here. So now in this, the same diagram is here. This is what is A, this is what is B, this is what is C. That is why R is C. This is C. Look at this direction. this direction like this. So C is equal to A by A minus B. A minus means this minus this. If B plus C is equal to A, what is C? A minus B. That is this minus this. What is R12? That is using this basics. R1 minus R2. In the same way, we can calculate R21. What is R21? R2 minus R1. That is what? The same diagram like this. Now vector like this. This is a direction. This is a direction position vector. Now direction is still. These two directions are same. With respect to this, this is the direction. Then apply this. A, C. A plus C is equal to resultant B. What is C? B minus. This is B minus A. That is this minus this. So using that is algebraic addition of vectors. Let us calculate what is this, what is this. This is equal to this. This is equal to this. Now the Coulomb's law force vector quantity, that is magnitude into multiply the magnitude into a unit vector, that is position vector. So for this one position vector is R12. For this one position vector is R21. So unit vector, sir, it represents direction, it represents magnitude. Unit means carrying only one magnitude. Magnitude value is 1 and direction. So that is when you multiply, what is that? This when you multiply the vector form of Coulomb's law. Vector form of Coulomb's law. The amount of force acting on this charge in the vector form is this. The amount of charge acting on this charge, the vector form is this. Then rewrite this, what is that? You know that, what is the unit vector? The vector divided by magnitude is the unit vector. So rewrite this unit vector is equal to this vector divided by magnitude. What is magnitude of this? This is magnitude of this. This is magnitude. This into this gives same thing. Unit vector is vector divided by magnitude. This becomes R2. This is already magnitude, magnitude 1, this is R2. So this is final, that is these two amount of forces are same, but negative because of this 1 and 2, 2 and 2, opposite direction. So this is vector form of Coulombic force. This charge, this is direction, is this. This is a vector form of Coulombic force on this charge is this. This is the direction. This is the position vector. Position vector. That is why. So this is vector form, but these values are same but in opposite direction. So this is a direction. So this is a vector form of Coulomb's law. That is a scalar form of Coulomb's law. To calculate the magnitude of force, we are using this just to calculate the magnitude of force of attraction repulsion. But we also see that value, magnitude as well as direction of force. So this is a directional force representation by this. Mathematical representation, that is a geometrical representation. Here a mathematical representation, geometrical representation. So there is this, let us wind up this with